Welcome to Chapter 4. In this chapter we're going to look at a few fundamental concepts of Qt. And I wanted to show you some of the programs that we talk about in the text. First thing we're going to look at is signals and slots. They're how we pass messages between objects in Qt. So we have this little program I've already opened up. This is actually in your book. It's referred to as Console Timers 1. So this is our first time using signals and slots. And what we're doing is we're actually going to create a timer object. It's actually defined in our class. Let me split the window up. This little button here is allowing me to split the window, so I'm going to split it. And since I already have it open, I'm going to pull that down and select the class definition. So we have a timer catcher. It's a Q object. It has a slot called catch expired timer. And it also has a QTimer. A QTimer is a simple timer you can set in terms of seconds and it fires a timeout signal. So up here you'll see the first thing we do is connect the timeout signal to our timer catcher slot. Alright, so whenever a timeout signal is generated, catch expired timer will be called. We then set the time to 5,000 milliseconds and we say it's not a single shot, which means it'll continue forever. With that sort of brief introduction, let's run our little code. Now we're building for the host this time. We're actually interested in seeing how Qt works, not necessarily proving that it works on the Raspberry Pi. It was a very, very quick build because it's already been sitting around pre-built. And you can see about every 5 seconds, actually exactly every 5 seconds, we're printing out the get timeout message. Alright. Now down here we can actually look at our application. See it's running. I'm just going to stop this because if I don't, it will never stop on its own. Alright, let me close this one up. And let's look at our second iteration. I'm also going to close this, this, and this. If you hadn't guessed, clicking the little X closes those. To File, Open File or Project. And let's go look at the second iteration of Console Timer. Again, we're going to build for the 512 desktop. Let's configure it. Go into that window, open up the new timer catcher. Let's go look at our class definition. Actually, I'll put the class definition down here and close that down. Alright, not much has changed. We still have catch expired timer. We still have pretty much the same thing in here. So what's different? That's an interesting question. Let's go look at main. This time we've added another timer. It's in main. We can do that. Timers do not have to exist in a Q object. And we're going to get every second this timer is going to fire and it's going to do this. Now you may be wondering what that is. That's a lambda function. A lambda function is think of it as a function you can just define on the spot. It's been around other programming languages for a while, but in C++ 11 it finally made it to C++, and it's one of the better features, I think. So what happens is we'll basically every second we'll execute this little function which will write to A out, which is captured. This is what they call capture. It's going to print tick. So we're sort of showing two different timers going off, both with signals and slots, and we're showing how to use a lambda. So let's run this one also. All right. Now, I should go back and correct this. But this is a great teaching opportunity. I find some of the best teaching opportunities are of small mistakes. If you notice, the name of the project is the same, but I'm running new code. It doesn't know that I've changed the code. The make system isn't aware of the fact that the code is not the same as before because the file names are the same. The dates on the code itself is much older than the executable. So we got to do up here is go up and we're going to do a rebuild of the project. And what that will do, if we look at our compile engine, you'll see we first remove everything, so we clean the project. Now it will rebuild, and we'll get our expected results. There we go. Again, that's probably one of the mistakes I make more often because I'll have several versions of a project open sometimes, trying different things. And if I don't change the build directory, I end up not really building what I think I did. And I'm not alone in this, but I will admit that I have spent sometimes a day trying to figure out a bug, why a bug isn't solved, only to discover it's because I'm not running what I'm actually testing. So here we go. Here we have this running. We can see we have 2 signals and slots, and everything's coming out pretty much as we expect it. All right. So I'm just going to close this window, which will kill off the program. I'm going to close up this project. Close up these pieces of code. And let's open the 3rd version of the consoles project. Again, remember all these are in your repository so you can play with them. And I do always encourage, play with the code, change something, see what it does. I'm a very much of a hands-on person. The more I play, the more I change, the more I learn. All right, let's look at our main again. That looks pretty much the same, so we're still going to get the ticks there. And let's go down here and look at timer catcher. Okay, now we've got something a little bit different. As you can see, we have 2 different methods here. And we're connecting to, let me just move this up. And one is made with a direct connection, and one is made with a queued connection. So if you remember, direct connection, it works exactly like a method call. And a queued connection, it queues the thing up so it doesn't happen until it's done. So let's run it this time. And again, let's go down here for a second. There's one more thing I should show you. We're actually emitting a new signal. Let's go look at the timer catcher H file. You see we now have this new signal called new count. So when the timer expires, it calls the catch expired timer method, the slot. We then increment a counter and we emit a new count, then print our old get timeout method. Finally, we should be able to look at that because this is emitted and we're connecting to it. So the new count is connected to both direct and queued count printouts. And those will basically say this is the direct count output and this is the queued count output. We emit the signal is then sent to both slots. But I want you to watch when the slots receive them. Okay? So let's do that. There's our little ticks. We got timeout. And guess what? I did it again. Remember what we do here? I'm just going to do it slightly different. I'm going to clean the project this time. It has the same effect. Gets rid of all the old code, all the old built objects. And now I'm going to build and run it again. There we go. Interesting. Our direct connect came out first and our Qt came out later, although they were both emitted at the same time. The reason being, if we look back in the code here, as soon as I do the emit, the direct connection is invoked. It's before we get the timeout printed. So if you look over here, you see the direct is printed before the timeout. The second connection is a queued connection. So that message is queued. So it's not executed until we leave the catch expired timer method. And I'm not saying that occasionally I've actually seen the tick come after the queue count, but today, just because of how things are working timing wise, it's coming before. So that's demonstrating the direct connection versus queued connection and how that affects when the messages are actually acted upon. It's important to remember that because sometimes you'll have a queued connection and not realize that it's not going to happen until after the method leaves, but you've already you've written your code so you depend on the action completing before you leave the method. So that's a good thing to remember. So we're going to close this project up now. Again, close these down. Now, code's still running, so just close it up like that. Yes, close the window. All right. Now we've talked about signals and slots. Let's move on to our next topic, which is Qt's implementation of introspection. So introspection allows me to look into things, look at things inside an object. So normally in C++, once I've written the code, I can't see it. But this time, what I'm going to do is I am going to use introspection to allow me to look into it. So let's open up our next project. We're going to first look at a Qvariant. Now, Qvariant is one of the most powerful things in Qt. You'll learn more about it in the upcoming chapters. But it allows us to basically pretend to be almost any class. So let's go configure the project. And as you can see, there's only one source file. Up here we define a Qvariant. We set its value to an integer 10. We then do math on it as an integer. We then print it out as a string, a boolean, and a list. Okay, we then create a Qvariant list. We put some values of Qvariants in it, and we will then print that out. We're using Qdebug, which is part of a very powerful logging mechanism that's discussed towards the end of the book. You can use it just as it is. You'll discover all the real powerful things we can do with it a little bit later. So let's run this now and see what happens. And it did all of its work really, really quickly. So let's take a look at how the output expects. So the first thing we did is print a Qvariant. It was calculated. We get the Qvariant as a string. We multiply it by 41. Then we print the result, which we calculated in Y. That works. we print out as a bool. In C, C++, 0 is false, anything else is true. So the value comes out to be true. We print it out as a list, a Q list. And it's actually an empty list because it's not a list. So we just create a list and we added V. And you can see it was added as a Qvariant of type int with a value of 10. We add the value of 1, a Qvariant value 1. Again, type int, value 1. 2.3 is a type double with a value 2.3. And finally, we have a Qvariant. It's a Q string containing hello world. All right, let's close this one up now. And we'll close this file up. And let's move over to a more interesting example that uses Qt's enumerations. This is the persons example. All right. The complete person example. Look at the person in the H file. So we've started using Q properties so we can work with things. So we talked about the properties as being a named thing that we can access through a common way. All right. We also defined some enumerations with the QNum. We define the enumeration, then we tell it that it's a special enumeration. All right. Now, let's look at what we're going to do with this person class. So up here in main, again, this is a console application. This does not even invoke, if you've been following along, you'll see a Q application or Q core application. We don't even start that. We just are using these classes without any of the graphics or some of the other features of Qt. This is just purely Q object introspection. So we set a property called name to John. Set the birthday. I'm actually a little bit older than that, but I don't want to tell lies too much. We set my sex. We set my hair color. Now this one is added dynamically, because if we go back and we look at person.h, I have a property of name, birthday, and sex. I don't have a property of hair color. But because of the property system, because of the property system, I can define on a Q object a new property on the fly. So I've decided this person will have a hair color and the value is brown. Now here we actually print out all the properties. Notice we just use the name of the class, property, and the name of the property. Okay. And then we can actually call them just by function name. There's a function that allows you to access them easily. Looking back here, we say the read function is called name, and the write function is called set name. So we use those, same with birthday and set birthday. So we just call name, birthday, and sex. Down here, we're going to actually get all of the properties out of the class and dump them. See, I can't go in and do p.hairColor because hair color is dynamically set. But here we get the static properties, the ones we define in the class, and here we'll dump all the dynamic properties. So, without further ado, let's see this work. So we can see we got the properties we expected. Name, date, right across the line. Again, notice that, oh, you're probably wondering why Qvariant int is 0, because it's actually enumeration. The enumerated value, if we look back in person.h, the first enumeration value is 0, 1, 2, and 3. I actually love Qt Creator. For, you notice how I just put my mouse over that and it showed me what the enumeration values are. There's some, as you explore Qt Creator, you'll find there's those sorts of neat little things like that. All right. So this time it's going to get the attributes and just print them out. Let's see if I can find that code. We're actually getting them from the function, so they return what we expect. All right. And this is actually the enumerated value. Notice how the QDebug prints out the enumerated value. The class is person. The enumeration value is male. It's not the number. It's actually the value, the text. All right. Then here we're getting all the properties via iteration. So all our static properties are object name. Yes, every Q object has a name. We aren't using it right now. The person's name, John. The birth date gives me the date. The sex, it gives me, again, 0. All numerations reduced to an int. And the numeration value is 0. Now notice dynamically, we were able to pull out hair color this time. So that's our quick sample of using the introspection system in the property system to have some fun. It's very powerful. I actually use the Q properties many, many times in my code. I just find it's incredibly useful. It's hard to say more about that. All right. Now, let's go up and open our final example code from this session. Now this is a piece of code which I believe I rewrote several times. When I was trying to get my mind around model view, what does that mean? What does it mean? And so basically we know we have a model and we can have different views of the model. So what I wanted to do was see what the different views do. So I set up a little screen. Let me shrink this down. So up here, we'll look at it has a list view, a tree view, a table view, and a column view. So we're going to use the same data model. Let's see what happens. Actually, before we do that, we're going back to the edit. And I want to actually show you main window.h. Sorry, main window.cp. So for each one of those views, we're using the same model. We use set model to set the view the model is on. Okay. Here we build the model. You can decide how, if you want to actually learn how that code works. It's just sort of a brute force XY type thing with a little bit more identification, so things are easier to see. So really there's not much code. We point our things towards the model, then we fill the model up. So having done that, let's run this. Now this is a GUI application, by the way. And here's our output. So it has a list. We got 1, 2, 3, 4, 5. We only got the first cell. As a tree view, I'll skip the tree view. As a table view, you can see we got, rows and columns. 1, 1, 2, 2, 3, 3, 4, 4. And 1, 1, 1, 2, 1, 3, 1, 4. 1, 4, 2, 4, 3, 4. So it makes sense as we build this model out. Column view is a little bit different. See, in column, starting at 1, 1, we have 1, 1, A0, A1, and A2. What does that mean? Let's look at our tree view, because that sort of shows it. A tree view allows me just to keep expanding down. All right. And I went 3 levels down. So tree views are great when you have hierarchical data you want to display. As you can see, so we have 1, 1, same as this cell, and this cell, and this cell, and this cell are all the same. We then drop down one more level, which we see here. We can then drop down one more level, which we then see there. Okay? Notice how that sort of moved across when I clicked it in the column view. Let me make these columns a little tighter. So similar thing, and we'll expand it out. This way you can actually see the data spans out hierarchical across columns. This way here you see it has a table, a tree view. So that gives you an idea of what the model view looks like. We'll get to using it in a chapter or so, but this really gives you basic fundamentals you need to know for Qt. You need to know about signals and slots, you need to know about the introspection system, and you really should understand the model view system. So thank you for following along, and we will conclude this recording. See you in Chapter 5.